This is a Farm Doc Daily webinar. I'm University of Illinois Extension's Todd Gleason. Thank you for joining us today. This one's called Connectivity and Edge Computing for Digital Agriculture. Deepak Vasisht is here today to take us through a series of slides on something that some of you may have on the farm or have been working with a little bit, but most of you will have very little idea about, and I'm really looking forward to seeing it. Thank you, and welcome, Deepak, for being with us today, and the floor is yours.
Thanks, Todd. Hey, everyone. I'm Deepak Vasisht. I'm a professor at the University of Illinois in Urbana-Champaign. I work broadly in computer science, like that's my primary domain. Before here, I got my PhD in computer networking as well from MIT, and I work broadly on various kinds of networking technologies, such as 6G, satellite networks, but I'm also interested in working on agricultural applications of these technologies, and that's where I'm coming from. I lead the networking part of the Center for Digital Agriculture at University of Illinois, as well as the iFarm testbed that we'll talk about a bit. Today, I'm going to talk about connectivity options as well as challenges in agriculture. This is work that I do with my colleagues here at UFI, as well as a lot of my students who actually do the work. I'm just kind of presenting on their behalf. So today, the goal for me is to walk you through various options and challenges for connectivity on the farm. So as you would know, connectivity is very critical for modern digital agriculture applications. It's estimated that rural broadband connectivity for agriculture can contribute up to $500 billion additional global GDP by 2030. And it's not just that, right? Connectivity is not just important for more agricultural productivity, it's also important for our communities, right? That there is increasing focus on e-learning, e-health, access to the internet. All of that is driven by having good connectivity or good connectivity for your devices and good networks for your devices. However, if you look at the applications that are being built today, about half the farmers in the United States do not have adequate internet access on farms. And the stress here is on the word adequate. So you may have some kind of access, but it may either not cover your entire farm or large parts of your farm, or it may not be good enough to support applications that you want to support. So if you want to join, say, a webinar, then you have to kind of be in a specific part of your farm to be able to join that. And fundamentally, if you're looking towards designing farms of the future, we need to have connectivity solutions of the future to develop them. And let me talk about some example applications for rural connectivity. And one application, for example, is these modern tractors or farm robots that need continuous connectivity. They sometimes need to stream videos. If they see something interesting, for example, if they see a pest or a weed, they may want to share that picture with you. But if you don't have connectivity, you can't do that. If they get stuck, you want to control them and move them. You need connectivity for that. So there are many applications for connectivity, and a lot of these require what we call high bandwidth. Like high bandwidth means that you have to be able to stream large amounts of data, such as videos from these farms. And when we think of farm networks, there are two parts of the network to think about. There is connectivity within the farm, that how do you connect, say, sensors, cameras, robots, drones, tractors, all of them to each other within the farm. And then there is connectivity to the internet. So if you have multiple parts of your farm in different locations, then you need to bring all of this data together and connect that to the internet. So there is connectivity within the farm, and then there's connectivity from the farm. And in our work, we care about both types of connectivity. Today, we kind of focus more on this connectivity within the farm, as well as connectivity to the farmer's home or office or the internet. So let me also talk about different applications and what kind of requirements they have. So I'm deliberately picking applications that are more researchy as well as more data intensive, just to show the limits of what we need. So one application, for example, is just imaging. So you have cameras deployed in fields, and you want to get video from those cameras. And just that would require about 20 to 80 megabytes per acre, or 50 to 200 megabytes per hectare. And you would need these like multiple times a day. For example, if you want to check in on one part of your field, then you would spend that amount of data. And if your network is fast, then you can get that data fast. If it's slow, then you have to kind of wait to get access to the data. If your network does not exist, you can't do it. There's also some research in using thermal cameras for, say, figuring out heat stress in your crops, or multispectral cameras for estimating plant health. These are specialized cameras, so they collect a lot more data. And as a result, we need to ship a lot more data off these devices and have better connectivity requirements for them. There are also need for very low latency connectivity. So when we talk about networks, there are two important factors. One is the bandwidth, that how much data can we push through, and then there's latency, that's how fast can we get this data from one point to the other. So the application that I mentioned earlier, that if you have a robot, you want to control it, it requires both kind of high bandwidth, that you have to be able to see the video that the robot is seeing, and then you have to be able to control it. And controlling it requires like fast response times, right? So if you move it, it has to move right away. If there's a lot of delay, then this process becomes very, very complex. And of course, there are other use cases of connectivity on farms, like sensor data collection, getting data from new tractors. Like all of that has similar kind of requirements in that range. So first, let me tell you about some of the challenges that exist in terms of connectivity, like why is connectivity hard on farms? So one reason is that you need to cover long distances, right? Typically, like if you have, think about deploying a Wi-Fi network at your home, right? You have a Wi-Fi router. It will cover maybe a few rooms, or 2 rooms, 3 rooms, that's it. And you have to then deploy a mesh network to get more connectivity if you don't get connectivity in parts of your home. But farms are much larger. So if you have low range devices like Wi-Fi, then you need to put a lot of these devices in. You need to connect power. You need to connect backhaul connectivity to these. Like all of that is not super convenient, and it takes a lot of money and time and maintenance, and all of that is not good. So yes, you need long range connectivity for farms, which is typically not well designed. Farms also have crops and canopies. So if you put a sensor below the crop, for example, or a robot is going under the crops, these crops and canopies will block the signal, so they reduce the range. So on the one hand, you want long range, but then you have these crops and canopies that are blocking the range. And this effect is very high for sensors that are operating below the crops. And of course, there is the need for usability. You want these devices to be low power because, again, you don't have as many power sources at different parts of your farm. You want it to be easy to set up and debug. And you want the network management to be easy. You don't need to, you should not have to call an expert every time you're deploying or updating this network. So there are these 4 kind of key goals that we want these networks to be available on farms. We want them to have long range. We want them to support high bandwidth, and we want them to support mobility. Like when devices are moving, we should be able to connect to them. So I'll talk about some of the options that exist today, and what are the challenges with them. So for example, there is cellular connectivity, right? You have the one that we use for our smartphones. It is long range, like it works at long distances. It can provide high bandwidth. You're probably watching this seminar on a cellular link, so you get high bandwidth. It can support mobility. Your device can move, but it's not always available. So Networks are typically deployed in areas with a lot of population so that they can make money out of those subscriptions, right? On farms, there's not as much population, not as many subscriptions, so there's not as much network coverage for cellular networks. There is an interesting new technology out there called LoRa, or long range. A lot of the farm sensors use that. It is available, it is easy to deploy. It's like Wi-Fi, but it operates at long ranges. But it has very low bandwidth. So it can only support few kilobits per second, which means that you can use it for collecting sensor data, but you cannot use it for collecting, say, videos or teleoperating robots on the farm. But it supports mobility as well. So this is one of the dominant forms of connectivity for sensors as well as like data collection on the field. I don't know if you've heard about emerging satellite connectivity options. For example, Starlink by SpaceX is one company that's building these satellite networks with low Earth orbit satellites where you can directly connect to satellite. These networks are available across the globe at this point. They offer long range. They're available any part of your farm. They're expensive. They are high bandwidth, depending on like if you're above the canopy or not. So they can be low bandwidth as well in some cases if you're below the canopy. And the support for mobility so far is limited. So I have another experimental network out there. I'll kind of skip this for time. So our goal is to develop on these existing solutions and build new solutions that can overcome the challenges that still exist and deploy in the agriculture scenarios. So one of the key or two of the key solutions that we're looking at in our test bed are Citizens Band Radio Service, or CBRS. This is a new technology or new regulation that allows users to deploy their own cellular network. So same as how you deploy Wi-Fi at your home, you can now deploy a cellular network. And anyone can do that. Like I can do that, you can do that. You don't have to rely on, say, an AT&T to come and deploy a cellular network in your community. You can do that on your own, as well as satellite networks. So we're looking at these two in quite some detail. We're also looking at what we call edge computing. Edge computing means that you don't have to necessarily transfer all the data from the farm to the cloud or to the internet. Instead, the devices themselves can be intelligent and make some smart decisions. So for example, if I have a camera on the field, it can figure out what the important images are and just send the important images rather than sending everything to end users. So, and we are also building like new kind of data modeling and visualization solutions using an app called the My Farm app, which we're building right now. So today I'll talk a little bit about like the connectivity piece, and then I'll take questions. So the issue with our thesis is that in the current forms of connectivity, the issue is that they need dense forms of connectivity. So for example, if I have to cover your entire farm with cellular networks, or multiple farms in a community with cellular network, then you need to deploy a lot of these towers. You need to extend power to them. You need to extend connectivity to them, and that costs money, right? Like it costs money to deploy fiber. It costs money to get power. It costs money to build these towers and get the hardware and all of that. And farms are large, so you have to need a lot of these towers to form a mesh network, and that's a problem. This is clearly not financially viable for companies or communities to deploy on their own. So our observation is that for agricultural applications, the demand for connectivity are sparse, and they're sparse in time and space. And what I mean by sparse is that if you are operating on a farm, you're only working on some parts of the farm actively on any given day. So for example, during seeding and harvest, there's a lot of activity, but there's like not a lot of activity during other days. So there is periodic patterns in time and space that you're operating on parts of the farm every day, and then these parts change every day. And then the days you're active also change over a season, right? So can we leverage this these kind of patterns that exist in agriculture to deploy more robust solutions. So one idea that we are working on is what we call bring your own network. So the idea is that instead of deploying these towers, can I use this new form of connectivity, which is CBRS, Citizens Broadband Radio Service, for communications between machines as well as people. So imagine that I have a tractor. This tractor, I put a dish on it to connect to the satellite and a CBRS base station on it to provide cellular connectivity. So now this becomes a hub that can move to different parts of your field wherever you need connectivity and collect data from those pieces. And this works actually in a very simple way. You can this is very much like a cellular network. So you can connect your phones to it, you can connect devices to it. You just need to give, and you can give out your own SIM cards. You don't need to rely on anyone else. Like this is your network. And you can bring your network to any piece of the field. This can be collaboratively done at a community level, can be done at a big farm level. You can move it to different parts of the field when you need it, as you need it. So there are many benefits for a technology like that. So just to illustrate one example for why this is interesting, on the left you see a dense mesh of cellular towers that would be required to cover, let's say, a large farm area. So you need maybe like 9 towers in that case. But as I said, you're not working on all of those areas on a single day or at the same time. So if you use this BYON model, you can have one device that moves to different parts of the field with this tractor or a trailer, and can be deployed at that location on that day and can be used for many networking connectivity tasks. So yeah, so the idea is to extend the coverage through motion as opposed to extending the coverage through dense deployments that are capital intensive and require a lot of cost.
Hey, Deepak, I have a question on
Yes.
that that I'd like to ask at this point.
Sure.
Would you need to be connected to the satellite with the bring your own, or could it just all operate without satellite connection and then be,
Yes.
once you get someplace else, get back, upload the data? I suppose it depends on what the robots are doing, but if you're just collecting data and or running the robot, maybe even with video, could it be done all from the tractor cab?
Yeah, that's a great question. So in principle, you could do almost all of it from the tractor cab without relying on the satellite, unless you need something from the satellite in real time. So for example, if you're interested in latest weather information, then you need connectivity to the internet, and that's where the satellite comes in. But there's a lot of things that you can just do with from the tractor cab itself. So I really like your idea of waiting for essentially updates when you're in connectivity zones, but otherwise just use the tractor as it is. So yeah, that works as well.
Yeah, and just as a reminder to everybody else, if you have a question, you can put it into the question box. That's in the GoToWebinar control panels, and we will see them and get them answered along the way or as we finish up. Yeah. CBRS is next.
Yes. So I just want to show you our current kind of setup. So the CBRS base station we put on this tower here on the left. I hope you can see my cursor. This is the top left device. This is not the round antenna, but the cylindrical kind of antenna that's out there. And this is the one we use for doing measurements on this cornfield. I'm going to report some numbers from last season, just to give you a sense of how much of an area it covers and all of that. So we did multiple experiments through the season when there are no crops and the device is above the canopy, so there's no blockage because of crops. You get a range of up to 3.6 kilometers or about 2 miles. And when there are crops or you're putting devices underneath the crops, then the range is smaller because of the crops. It's about 1 kilometer or about 1/4 of a mile. And then I want to show some numbers on upload and download speeds. So the download speed on this network that we got was about 100 Mbps going down over time, which is similar to what you would get on a 4G network. This is essentially a 4G network deployed by us. So it's very similar to a 4G network speed. You can have 5G versions of it, but the 5G versions tend to be more expensive. The 4G version, the base station is about like 5 to 10K, depending on who's selling it, right? And it keeps getting cheaper, I would assume. And then the graphs here are the upload speed with distance. So the x-axis here is distance. So the horizontal axis you see is distance. The y-axis or the vertical axis is the speed. You can see that the speed kind of goes down over time, but even at long distances, you can get about like 5 Mbps upload. The max is about 15 Mbps. And then when there's crops later in the season and we are operating under the canopy, the upload speeds are smaller, especially when the crop canopy is thick in the mid-season. But I'll show you some experiments for how good this is anyway. So this is my last slide. I'll leave some time for questions after this. Just want to show you a demo of everything working together. So this is our network. On the top left, I have my student who's trying to control this robot on the field. At the bottom left, you see the robot moving. On the top right, you see what the robot sees. This is just a camera feed from the robot. And the bottom right, you see where the robot is at any given instance of time. So as my student controls this, the interesting bit here is that this is a CBRS network, the same like BYON setup, the bring your own network setup that I was showing you. And in this network, my student is able to stream video, which is a high bandwidth application at very low latencies, and they can control them. Like he can control this robot very precisely in this field, even as it's navigating these complex crop rows. And he's been able to do that at a distance, right? So the red dot here is kind of far from the farmhouse, which is where our base station is. So this is how this works end to end. We're still kind of testing this technology out this season, trying to make it more robust and improving it. And all of these activities that we're doing are happening at our Illinois Farm of the Future test bed. We post updates about this on this website called ifarm.illinois.edu. So if you're interested in learning more, please visit this website. We can also send you emails. If you want to sign up for periodic updates, please go to this URL, go.illinois.edu/ifarmupdates, or scan this QR code. You'll be taken to a form which you can fill to have more updates from us. So that's all from me. I'll hand it over to Todd for the last couple of slides, and then we'll take questions.
And we will take questions for Deepak in just a moment. A reminder that we do have sponsors here for FarmDoc. They include the TIAA Center for Farmland Research. That's right here on campus, farmland.illinois.edu. It's part of the FarmDoc team. CoBank, Compeer Financial, Corteva AgriSciences, Farm Credit Illinois, FS Growmark, Illinois Corn Growers, and the Illinois Soybean Association. We thank them. Our FarmDoc educational partners, and of course, include the College of Agricultural, Consumer, and Environmental Sciences. We refer to ourselves as ACES. The Department of Agricultural and Consumer Economics, that's where the FarmDoc team mostly belongs. And of course, University of Illinois Extension, the Gardner Agricultural Policy Program, and FBFM. Of course, we thank you for joining us as well. Just a reminder, if you want to visit us online, you can do that most easily at farmdocdaily.illinois.edu. There are a series of FarmDoc sites. farmdocdaily.illinois.edu is the news site, so it's a running set of blog posts from the Agricultural Economist and a few others from time to time. The FarmDoc site, which is farmdoc.illinois.edu without the daily in it, is the place where you go get all the tools. And there you can download all kinds of spreadsheets for the farm and other tools that are available, including things about crop insurance, as well as some information about marketing, and a series of other calculators as well. Don't forget that Jim Baltz, who's behind the scenes, thank you, Jim, for being there again today, will have this video up on our YouTube site probably by the end of the day. I'm sure he will. In fact, he almost always does. You can find that at youtube.com / @FarmDoc, and all the other FarmDoc videos are there as well. The 5-minute Farm Docs, my radio programs are there as podcasts on YouTube. Now, if you've got questions, go ahead and put those into the question box, and we'll get those answered. Why don't you go ahead and turn on your camera as well, Deepak, and I'll turn mine back on for this part of the program. And we'll get started with the first question. Actually, again, comes from me. You are not in the College of ACES, though you're affiliated. You are a computer scientist here on campus?
Yes, I am a computer scientist.
Yeah, can you tell me about the affiliation between you and the Center for Digital Agriculture?
Yes. So I lead networking in the Center for Digital Agriculture. So I'm a computer scientist working on networking research, but I'm also interested in agriculture in general. I worked at Microsoft in the past, where I worked on their agriculture solution called FarmBeats as well.
Yeah. We do have a question from one of our viewers today. They ask, can you please speak to any preliminary work or discussions, particularly the security concerns, any policy and standards that are under development, those sorts of things?
Yeah, so there's a bunch of different work going on in terms of privacy, security, as well as access and policies. So in terms of like the networking part of this, the most interesting policy thing for me is the CBRS spectrum in itself. So traditionally, like spectrum is owned by entities like cellular companies who use that to provide connectivity. The CBRS band was opened only like about 5 years ago or so, where it allows citizens to deploy their own networks, especially in areas which are undercovered, and that gives us the ability to deploy like networks like these, where your own cellular provider, right? So you can deploy cellular networks in your own locations, and all of these like discussions happen at the FCC, which is the ones that I follow. Of course, there are security concerns as well as privacy concerns with the data being collected, right? That who owns this data, who owns the models that are being trained on this data. And that's a broader question in terms of like multiple, like with AI, there are questions around who owns this data and who can train models on this data. These questions are broader than just agriculture, but they're also agriculture specific questions, right? That who owns the data being collected on the farm? Like if a tractor that you're buying from like John Deere collects this data, do you own this data? Does John Deere own this data? I know there is a lot of like discussion going on that front. I personally do not like work in that space. There are experts in privacy and security who work more on those kind of questions.
Is there a difference between the CBRS, the Citizens Band Radio Service, and what we're used to using in our automobiles, sometimes the truckers use, and that farmers will use simply shorthand as CB or Citizens Band?
So I guess it is kind of similar. I am not sure like what technology the Citizens Band, like the radio, the Citizens Band use. Specifically, like this one is meant for broadband, like the CBRS one. So it's not just like a narrow band kind of audio link, but you can transfer large amounts of data on this.
Okay, so it is. So it is different. The Citizen Band would only be audio.
Yeah. Yes, exactly. So here you are. Getting essentially a 4G service being deployed by users. Yes.
And for clarification, what's the difference between Bring Your Own and the CBRS?
So Bring Your Own is just our model of deploying like CBRS in a mobile.
So it is just the way CBRS. You would deploy it. Gotcha.
Yeah.
All right.
Yeah.
And if you've got questions, we'll talk for just a couple of more minutes here before we let Deepak go. You can put those in that gray box. So these networks, the security issues related to them on the Bring Your Own Network, the CBRS? How open are they at the moment? Because you said that they appear like they're not very open, but I'm wondering how open they might be. Because and I'm just thinking out loud that it might be possible to sniff them and
Yeah.
somebody could capture the data.
Yes. So I guess the networks themselves are well designed in a way that it would not be easy to sniff data of during transmission. Of course, I mean, there are things to be done about like the patterns in data. So for example, even though I can't see the data, but if I see like data coming from one part of your field, it can tell me a little bit about what's going on. Right? If I see like a moisture alert sensor going up, sending data, it can tell me something, right? But the data itself is secure. To me, I think the more important privacy questions arise at the end, right? So once you've brought this data to the tractor, what happens to the data then? Like, do you control it? Do you give it to someone to process it? I think those kind of questions are still important questions. I think not many people like know answers to them yet. There's still like deliberations around those questions.
What excites you about this kind of research?
Yeah, so personally, for me, I think the motivation comes from the fact that connectivity is like such an important piece of our lives, right? Over the last like 20 years, I think this has made one of the massive impacts on humanity as a whole, right? Like our lives have completely changed through connectivity. So just making it like more accessible, safer, is important, and that's what I work on. And also, I mean, like some of this stuff is quite cool. Yeah, so I like that.
Is there a difference between what the equipment manufacturers might want from you and what you're thinking about developing, which would be owned by the farmer or some other entity?
Yeah, so I guess I'm kind of like my research is not really like interfacing with the manufacturers or even like even farmers as much, honestly, right? Like I interact through extension and other like people in ACES, right? My personal research is largely driven by uh, let's say like mathematical models behind like what's going on, right? It's more theoretical than what I presented here. But in general, I think our role in academia is to kind of not be influenced by, say, like commercial interests as much, right? We want to be an independent voice, and focus on what's good for society, and kind of like be honest about the pros and cons of different options and let people choose.
Finally, before I let you go, what do you think is the coolest thing you've seen to this point related to your research in the field?
Yeah,
Could be a
so I
robot,
guess
could
there
be
are.
something else.
Sorry, what?
Could be a
Could be a
robot,
robot.
could be something else.
Yeah, so there is a couple different things. I think this demo that I showed is pretty challenging to execute. So I think when we saw that, I was quite impressed by my student who built this. I think that's probably like one of the coolest things in terms of connectivity in the field. It's pretty cutting edge. Yeah, but there's like so many cool things going on, like satellite networks. And back when I was at Microsoft, I had like Bill Gates do a demo of one of these things out to and he made a video. So I think that was pretty cool, having Bill Gates come and do a video with like farm robots and stuff. Yeah.
Yeah, very neat. So early on in the research for automation, or so that the tractors could drive themselves,
Yeah.
cellular interference, any other interference, always was an issue. I saw more than a couple of tractors in the field just go somewhere else. How much of an interference is there, and how much problem is that? I know I told you that was my last question, but I'm always got one more.
Yeah. No, interference is a big kind of issue in networking. So we are always looking for ways to improve that. But yeah, I guess the newer technologies we get, I think they're more robust, and they know how to better deal with interference. We're getting quite good at that.
Well, Deepak, thank you for visiting with us. We appreciate that.
Yeah, thank you, Todd. It's great talking.
Deepak Vasisht is with the computer science department here on campus at the University of Illinois, works with iFarm and the Center for Digital Agriculture. We appreciate you being here as well. This has been a Farm Doc Daily website, our webinar. This has been a Farm Doc Daily webinar. You have a very good afternoon.